This is Thanksgiving practice number 5. So we are going to first of all start by identifying our letters. We have the left man, the box, the right man, the ground, and the earth. So we're going to use the letter R for right man. We're going to use the letter L for left man. We're going to use the letter B for box, E for earth, and G for ground. Okay, so two men are moving a box which weighs 660 newtons. The man on the left, who weighs 825 newtons, pulls with 180 newtons. The man on the right, who weighs 670 newtons, pushes with 120 newtons. So we don't have to do any F of G is equal to M times G math. So let's draw our interaction diagram. This is the left guy. The left man is interacting with the ground. He is also trying to pull this box very hard. So we're going to give him that interaction. And he also is interacting with the earth. So the left man and the earth. The box is interacting with the earth, and the right man is interacting with the earth. Okay, he's also interacting with the floor or the ground. Okay, and the right man is also interacting with the box. That is our interaction diagram. Okay, we are going to say that they are not moving, or no, they are moving, and they are moving, it's a constant it's just a constant speed. Okay, so it's a balanced. We are going to write the left guy is being pulled by the force of gravity on the left guy by the earth, which is happening at 825 newtons. The floor is pushing up the left guy, the ground, at also 825 newtons. He is trying very hard to pull this box in this direction, so that means the box is pulling him in this direction. Okay, so left guy is pulling the box here, the box is pulling the left guy this way. So that means that the left guy is being pulled this direction. Pulled is F of T on the left guy by the box is at 180 newtons. That means that the force of friction in this direction, force of friction on the left guy by the ground, is happening at 180 newtons. Okay. The box is being pulled down by the force of gravity, or the force of gravity is pulling the box down by the earth at, the box weighs 660 newtons. It is being pushed up by the ground at also 660 newtons. The box is being pulled in this direction by the left guy. Box, left guy, and it's happening at 180 newtons. And he's also the box is also being pushed in that same direction by the right guy. So pushed on the box by the right guy, and it's being pushed at 120 newtons. And because we know it is a balanced force, then it is moving in this direction. Force of friction is causing the box by the ground at 180 plus 120, which is going to be 300 newtons. And now for the right guy, being pulled down by the force of gravity on the right guy by the earth is happening at 670 newtons. and is being pushed up by the ground, the right guy by the ground at also 670 newtons. Because the right guy is pulling the box in that direction, the box is pulling the right guy, or pushing back at the same amount of force. So normal force on the right guy by the box is at 120 newtons. This means that the force of friction is acting on the right guy by the ground at also 120 newtons. Now we're going to identify the Newton's third law pairing. So the first one is the force of tension on the left guy by the box, left guy on the box. There's your pair. And the other pair would happen to be the pushing between the right guy and the box. So right guy and the box.